So hello, I'm Jonas. I work for Red Hat on the display systems team. A lot of my time is spent on dealing with remote stuff. So I'm going to go through a bit of the history and of how things worked and how things ended up working and where we're going with it. Let's see how it goes. So yeah, start with history, and then after history ended, we started new with a new beginning. Later I'm going to just show a high-level GNOME architecture, how the whole remoting stuff works, and then see what's happening after this. So the history part. In the beginning there was X11, and it looked like this. It's a lie. It's applications, the window manager, and compositing manager. It's the same blob, but I'm separating it here to illustrate things. Everything is X11. There's no dedicated API, and there's an X11 server sitting in the bottom. Regular workstations with the physical monitors and everything, you have the same thing, but you have drivers below, and you have Xorg specifically above it. And then you have the screen sharing that you have on X11, which I see now that there's no different color when you export it to PDF, but when you're screen sharing in X11, it's just a regular application that talks to this old magical X11 API to scrape the contents of the screen. So in practice, it's just a regular X11 application that uses the same APIs that are available to clients and window managers and compositors, which is usually get the shared memory of a pixmap or a window, or do the same thing but with GLX to grab the contents of a screen or a window and anything like that. And then you use this thing that is not intended for remote desktop that is called Xtest. A wild guess it's that it came to be because of testing. But it was reused instead for remote desktop input injection. And then it acts like just any other application when it comes to scraping the clipboard to mirror to the remote desktop server. That's screen sharing. Then you have the other kind of way that a lot of people use GNOME is GNOME runs on a server somewhere and you access it through a remote desktop client. And then it tends to work a bit differently. It's not typically just an application. It's a special purpose X11 server that you rip out Xorg, you replace it with, for example, XVNC from Tiger VNC, and you start it in a special way, and it sits there and acts as the X11 server. It's usually Xorg forked to some degree, and then you replace the what is called the DDX part of it, more or less. And then there's also, you can also run, for example, the virtual frame buffer version of the X11 server, and then you have the same kind of API usage, screen sharing, but there's no actual physical screens, so it's still headless. But in this case, it's back again to just a regular X11 application doing things via the windowing system. And then there's this very complicated way that some can implement something called hybrid remote desktop, which is when you can switch between physical access and remote access. It's not really supported. You have to use weird hacks. You can configure your X11 server sometimes with some drivers to add virtual outputs, and then you can configure them, but then there might be some conflicts with the desktop environment who also wants to configure the same thing. So it's not really a thing that is possible in any sensible way in the X11 server, so there's no, it's a complicated story. So what are the key takeaways from how it worked? How did remote desktop work in the past? It was tied to the windowing system, even though there was no window involved. It relied on complete lack of sandboxing and isolation to being able to do anything, more or less. Or and/or replace the whole X server with something else to be the server. Desktop environments were not really aware. There were some clever hacks to look at extensions just to make some assumptions about if that kind of extension is there, then it's a VNC server and things like that. But the desktop environment was not aware. So there were no adaptations that could be made necessarily. And as I said, it was very difficult to implement like any kind of hybrid solution. And as I mentioned, there was also some vendor-specific ways to do some certain things. There's the NVIDIA FB something frame buffer that is NVIDIA-specific, and then there's some Intel-specific thing to adding virtual outputs to the Intel driver. But it's not a good story. So with Wayland, we had to start from scratch. There's no X server you can replace. There's no X11 lack of isolation. So let's start fresh. So first we set up some goals. Completely untied from the windowing system, because there's no windows involved. There's no presentation on the screen involved here. There's no point in tying it to the windowing system. Have some more explicit responsibility split between the remote desktop server, as in the thing that communicates with the internet and handles that, and the actual desktop environment. The right API level for the right use case, which practically means sometimes you need low-level stuff to have efficient plumbing, but sometimes you need a bit more high-level approach to the APIs to make the desktop environment and everything aware of what's actually going on. So, for example, don't use xtest for remote desktop input, for example. Use and create reusable components. So there are going to be a lot of complicated parts going on here, and you don't want to have a single gigantic API that does everything. So try to split it up a bit to make things shareable and reusable. Another big thing is be compatible with sandboxing. It was simply not possible on X7 reasonably, which means there must still be isolation. It must still be possible to limit for the screen sharing case, for example. And use modern API, no GLX specific extensions, and just use what is the gold standard now, as in render nodes for rendering and allocation, buffer allocation, DMA buffers for passing around hardware buffers around. And another goal, pave the way to make it possible to implement a reliable hybrid remote desktop solution. So the plan. A descriptive high-level controller API that is dbus-based, split into three. One internal for our platform itself, a portal that handles everything about sandboxing, and then one for purely remote desktop solutions. And then for the low-level plumbing, be prescriptive. Descriptive here means you describe the situation and on a high level, but prescriptive it's more low level that you ask for specific things, and you could say that Wayland is usually descriptive when it comes to window management, but prescriptive when it comes to like buffer allocation and state handling and things like that. And have one API for pixel plumbing, and then another for input plumbing. This is roughly how the platform API looks. It's a bit split up between output and input, so screencast for output and remote desktop for input. Primarily for screen sharing case where you don't want to have an application being able to control your session. It's session-based, where in principle it should mean that there's a session in the display server or desktop environment that corresponds to a client connecting remotely, so like a user sitting somewhere else. Some functionality is split in between input and clipboard is in the remote desktop, and screencast is just pixel plumbing. And then a stream just for something that we're going to go in here. So the thing that we started with here, the first reusable component that we wanted to use was Pipewire. I imagine everybody knows what Pipewire is. It started as a video streaming platform, more or less, for webcams and screen sharing, more or less. Later it grew into an audio server as well, and I think that's primarily what it's used for now. Everybody uses, or most people are using for audio daemon. But in the beginning it was for video. And then have so-called Pipewire streams for every kind of source you have. If it comes to screen sharing, then it's either monitors or areas or windows and things like that. And then make use of something Pipewire has, which is stream parameter negotiation, which can have a remote desktop server communicate with the display server to set up a Pipewire stream that does the things that is appropriate for a remote desktop server sometimes, and sometimes it's for screen recording, for example, then maybe refresh rates and things like that matters. On a bad internet connection, you want low refresh rate, then you renegotiate the parameters to be a slower monitor, for example, and you have a fast internet, then you can have 60 FPS and things like that. Input, let's forget about that now, because we started with pretty terrible method calls, but I'll get to that later. We started out with just dbus method calls. And now I'm going to go a bit about how it looks now in the GNOME world. So we have the display server on the left, where libmother sits below GNOME shell. It exposes this platform API that I mentioned. It's used by the screen recording, the portal, which I'm not going to go into details now, and now the remote desktop server. I'm going to mention slightly how it looks inside of the display server. So a virtual monitor and a physical monitor. The difference is obviously that there's no actual physical monitor when it's virtual. But apart from that, it kind of looks similar. In the Linux DRI rendering DRM world, there's two kind of devices. There's the render node and there's the card node. And in a physical monitor, you use the card node to allocate buffers because they need to be compatible with scanning out on a wire. While on a virtual monitor, you use the render node, which doesn't have any connection to the mode setting and output of it has no connection to KMS, so to say, really. Rendering is similar. In a physical monitor, you can either render to an FBO as in a frame buffer object or an AGL surface or something similar in Vulkan world. While in the virtual monitor, we always render to an FBO. And the presentation is the bigger part that is different. In KMS, kernel mode setting, it goes to the wire, the HDMI wire or a display port. But in the virtual monitor, Pipewire is practically replacing KMS here. And inside this display server, this is all abstracted with virtual connectors, virtual CRTCs turns into a virtual monitor, and kernel mode setting connectors and CRTCs turns into a physical monitor. But to everything above that, it's the same. Virtual monitors turns into Wayland outputs and our configuration API and everything, and the scene graph and GNOME shell. So from everything above that layer, it's the same. Input is similar. You see here this little new thing that I'm going to mention soon is what I'm going to mention in the next slide, I think. Just as with output, input is also some indirection here that physical input devices, they talk directly to the kernel via lib input, but virtual devices talk to something implemented by lib-a, which I'm going to go through in a bit. But in the end, above the backend in the display server, it's all the same. It turns into a WL seat and pointer devices and hooks up to the accessibility input parts and the input capture and everything. And the next step here, the remote desktop server, I'm going to describe in a bit more historical manner. So back in 2015, somewhat not in the beginning of the Wayland transition of GNOME, but in the early days of the GNOME Wayland session world, we had to have some kind of way to implement a remote desktop server. And what GNOME had back then was VNO. VNO sat in the application box of one of the earlier slides to do screen sharing. And that was the primary target for the initial days of GNOME Remote Desktop. So it was started around 2015, was aimed to replace VNO, which had its own libVNC server-ish fork, and were very tightly coupled with the way that X11 worked. So it was decided to create something new. And instead of having a fork of libVNC server, it uses the actual libVNC server library. It was, from the get-go, designed in a way to make it possible to add additional protocols by trying to make anything that is not tied to the actual remote desktop protocol outside of it. It used the descriptive internal platform API that I touched on briefly before. Pixel plumbing was all done through PyPower, but the input was still based on these dbus method calls, and was also only ever screen sharing. You can see where in the stack it sits. It sits a bit above the render nodes, but it sits like kind of GNOME, besides GNOME shell, because it's, even though it's using the API from it. Then the focus was turned somewhat to finishing the rest of the Wayland parts of the GNOME session. So it didn't see much progress in a few years, but then suddenly Pascal Nowak showed up with a lot of enthusiasm for implementing support for the RDP protocol. So he introduced that back in 2020 using the free RDP project, which from an upstream remote desktop protocol project point of view, it's much more active, it's much more featureful, it's much more potential, so to say. It saw a bunch of features happening, mostly by Pascal here, clipboard integration, even using a file system for this file transfer using clipboard feature that RDP has that maps nicely to one of the Nautilus clipboard MIME types. It got hardware acceleration with H.264 using CUDA as in NVIDIA, practically because Pascal had an NVIDIA card and you wanted to have hardware encoding. He added audio redirection in 2021, and then I went and added this new headless single-user remote desktop runtime mode back in 2022 as well. And then Pascal went on to add virtual monitor resolutions, which means you could resize monitors. And eventually, we decided in 2022 that we're simply going to replace the VNC option for like replace the VNC integration in GNOME with RDP, simply because it grew all these features. It was just much more feature complete than what we had before. So yeah, a lot of design went into fixing up the control center integration, and yeah, that happened. So yeah, this is the other thing that came to be. As I mentioned, reusable components. We had one for output. We didn't have one for input. So together with Peter Hutterer, he introduced this thing called libé, which is egg in German, but it stands for Library for Emulated Input. So it's a bidirectional IPC inspired a bit by Wayland, as in it's an XML file that describes the protocol, and then a binary IPC that actually implements it. It's libinput inspired in the sense that it's on the same level as libinput, as it doesn't deal with trying to emulate the hardware, it's trying to emulate the conceptual input devices. While it started with support for keyboards, as in key codes and key maps, pointers, absolute and relative, some buttons and touch, it's designed from the get-go to be extensible. And kind of right now we're seeing the fruit of that. We're getting more and more things, UTF, Unicode, keyboard symbols, touchpad gestures can be added to lib-A independently of everything else. Just needs the right plumbing in the endpoints. And right now, the work in progress that has merge requests open is even drawing tablet support, as in pens and all that stuff, and then keymap control. So this has also ended up being the same protocol and API used for input capture, which has a GUADEC talk from some years ago by Peter himself that you can go and look online. Just briefly how the remote desktop server is set up. It tries to share as much as possible in the generic parts, and then we have all these like protocol-specific implementations that sits in their own little areas. But it's still meant to be multi-protocol in its architecture. And since then, more and more stuff has been happening. We have this new libA thing, so we all went to replaced all the input method plumbing with libA, which meant not only got rid of that old DBoS methods, but we got more control, or the remote desktop server got more control about how exactly input works, and could do more things. Pascal went and added the multi-monitor support back in 2023, and Juan Torres, who also showed up and went and implemented remote login via GDM. There is a talk for that from an OpenSUSE conference some years back that I would recommend everybody to see to get some details about how that works. 2025, we got camera redirection and relative mouse movements. You can use GNOME Remote Desktop to actually play games, like first-person shooter games and things like that. Touch input also back last year. And then the newest things is moving away from being NVIDIA-specific when it comes to hardware coding and using VA API and Vulkan for further video encoding. Which means it works on more devices than before. And this year we also got single-user Kerberos authentication, because that has been a long-term problem with authentication in RDP and VNC, for that matter, that you can't use the password of the user to log in, which means you have to have a separate password, which is a bit awkward. So if you have Kerberos set up, which you probably don't, but then you can now use Kerberos. So what's coming next in the remote desktop world in GNOME? Let's see. One of the focus areas right now is get rid of the somewhat vendor-locked APIs that we have now. So everything that I mentioned when it comes to the headless access has been using our own GNOME prefixed private platform API. It has seen usage outside of it, which makes it a bit difficult to change, and it's like third-party solutions don't really want to be GNOME-specific when it comes to something that is supposed to work on more things, on more desktop environments. So that's why the current one of the current focus areas is introducing a specification to XDG specs, which is called org.freedesktop.remote desktop 1, which is a cross-desktop dbus API that specifically is designed for headless remote, headless and in the future hybrid. It's highly inspired by what we already have, so it's reusing all the things that we have added, Pipewire, Libé. It's very explicit about the remote desktop server being in control and driving the session so that it can conceptually be seen as a replacement for KMS and input eBdev. It's a great chance to get rid of technical debt. For example, the dbus methods and some stuff that can be migrated away from this API into Pipewire, we can finally do. So once this one is out and anything that is relevant has migrated to it, we can start actually cleaning up the platform API to make it actually a platform API. It's currently backed by GNOME, KDE, and Tiger BNC. We've been collaborating on this recently to get somewhere with this. So hopefully it's going to be more projects than that. And eventually also, like GNOME Remote Desktop, I intend to make use of this, that we can actually run GNOME Remote Desktop on KDE eventually. Next up, specifically in GNOME, multi-user Kerberos authentication. If you run free API for free IPA, you can integrate it with that to get to not have to have separate passwords and things like that. There are some ideas floating around amongst us in how to deal with this and regular people's machines, which don't tend to be connected to some kind of identity management system. But so there's something we're going to experiment as well to not actually make it so hard to actually make use. Juan is adding support for smart card redirection, which involves some components, the same with Kerberos. So that's something that we at least hope to get into 51. The smart card redirection already has the merge requests open, but not the Kerberos ones yet. Next on the agenda, hopefully then 52. Hybrid remote desktop. It's the thing that never worked well on X11. We can perhaps finally have a real go at having a real solution. To mention short, the idea here is that the display server is actually fully aware of this so that it can reliably turn off physical monitors when you're connecting remotely and then switch back and make it so that you don't risk having both open at the same time. So when you're connecting remotely and the monitor turns on when you're not there without realizing it. Currently lacks, while we can mirror the resolutions from the remote clients in RDP, we don't have the solution for positioning them. So that's also something on the next thing. And then future, even further back, drawing tablet, video encoding other than AV1, which then would be probably only free RDP client specific, but it's not too bad. Drive redirection, as in practically forwarding the file system from the client to the host or the other way. And Rails, which is, you can see as if you run an application on your GNOME system remotely, and then you go to somewhere else and you connect through RDP, then you can continue with the application you were running remotely, but integrated to your other system on your local machine. So if you have a GNOME builder running on your remote GNOME, then you can continue with the same builder instance on your local machine when you get home, for example. That was what I had.
Can you hear me? Oh. I think the microphone went a bit crazy and I made it worse. Thank you so much. If we have any questions, I'm happy to pass by and bring the microphone. In the meantime, people following online, feel free to send questions in the Matrix chat.
Hi. Do we have any idea on what the timeline looks like for this org.free desktop API that other desktops could start using, or other screen sharing tools or remote desktop tools can rely on?
So the idea is that screen sharing tool should never use this. It's portals that they should use because they need sandbox and everything. But timeline, it's always hard to talk about timelines in software. My hope is at least GNOME 52, if everybody can finalize on the details of the API. We're currently discussing details about how to deal with keyboards. For example, keyboards is a very complicated topic because some protocols, they send key sims and some send key codes, and some wants the layout to be mirrored, some really don't, and there's a bunch of details there we need to iron out. That's I think the bigger thing that we're working on right now there. But yeah, we'll see.
One more question in the room.
If I remember correctly, GDM had a long time the problem that it can't really initialize networking really, so managing was problematic. Are you now tackling that area so that GDM can also do network connection and also ensure that you can remote login by accident?
So with the remote login, GDM is not involved in any kind of network. There's no TCP or UDP or anything talking to GDM. Just very briefly, because it's a kind of complicated topics, but in RDP, GNOME Remote Desktop sits and listens to all the connections, and it creates a greeter, as in the login screen sessions via GDM, and then routes things around, and then eventually you get a real session. But it's GNOME Remote Desktop that asks GDM to do things, and it's GNOME Remote Desktop that has the actual network. So there's no network code here in GDM. It's externalized, so to say.
So I had a question. Is GNOME Remote Desktop itself sandboxable? Like, does it use the Portal Remote Desktop APIs, or does it also use some GNOME private APIs as well?
Right now it doesn't use any portal. It uses 2 or 3, depending on how you see it, private APIs. One is the platform remote desktop API that I mentioned, org.gnome.modern remote desktop and screencast. But for the login stuff, it uses org.gnome.displayManager, as in GDM's private API. But with the vendorless things, at least my idea here is that for screen sharing, you could use the portals and become practically an application that you just run. And then for For the headless access, then it uses the org.freedesktop.remote-desktop1 API.
Any other questions? In the meantime, people from home haven't sent anything, so thank you so much, Jonas.